Hi, and welcome back. I'm very excited for our next presenter. His name is Ken Latino, and he is actually the Managing Director at Prelical Solutions Limited. Be sure to check him out. He's going to be talking to us today about the practical reliability model. And before we do that, make sure and get the code at the bottom of the screen to play in the Play to Win session because there are a lot of prizes, and the competition is very stiff so far. So I'm going to hand it over to Ken, and he's going to take it away and tell us all about the practical reliability.
My name is Ken Latino, and welcome to my session on practical reliability. So just a little bit about myself. I'm currently the Managing Director of Prelical Solutions. Prelical Solutions, and I know it's a funny name, had a pretty low marketing budget, so I came up with the name myself, but it's the combination of practical and reliability put together. So I'm just a big believer in practical approaches to reliability. I've been around a long time doing this. Over 35 years, I've been in the sort of the maintenance and reliability business. And, I guess the one thing I really learned is, you've got to make things practical if you want them to stick. Okay. Now we can do a lot of, interesting things and a lot of, big approaches to reliability, but they probably won't stick if they're not practical. If the people in the field can't do them day in and day out and see that, it makes sense and it's giving us value, it probably won't stick very long. So again, a little bit about myself. I've been around for about 35 years in various roles. I started my career with a company called Reliability Center Incorporated in Virginia, and we were known extensively for some of our reliability approaches, and particularly root cause analysis. That's sort of a specialty of myself, and actually my whole family was kind of in that business, and my two brothers actually work with me at Prelical, so we're still doing that and still trying to help people kind of solve their sporadic and chronic problems. When I left Reliability Center, I went and worked with a kind of a startup company who was getting into a new field of software called APM, and that company was named Meridium. Today, Meridium is part of GE. GE Digital bought Meridium several years ago. But we built a tremendous tool to be able to kind of manage all aspects of reliability. So I really had a good time with that company and actually building that product up to where it is today. When I left Meridium, I worked at a large paper company. We actually were implementing the Meridium solution, and I was the reliability engineering manager for one of their larger mills, and we implemented that solution at several of our mills. Then I came back to GE after GE had acquired Meridium and worked in a product role to try to help, make the product, kind of really do practical things in the field. So I really enjoyed that role. And today I decided I would kind of, sail out of my career, kind of, doing my own thing. And I really enjoyed working not only by myself, but I also enjoy working with my two brothers who I've worked for years and years. So now we're kind of back together and actually going out and helping plants again. So really having a lot of fun. So anyway, that's a little bit about me. So the reliability performance model, what does that mean? And you'll see up in the corner there, it talks about, things have to be, practical or they won't take hold. So, when I was working in the field, an 8 or 10 hour day was not a typical day. So, people who work in an industrial plant find that there's lots and lots and lots of things going on. There's lots of things that take your attention away from reliability. So there's not a lot of extra time to be looking at, pie in the sky approaches to things. Okay, you really got to make sure that what you're doing is practical and it's actually adding value, and that it can stick and that people can actually apply it in their day-to-day ways. go, what's the problem? The problem is there's lots and lots of great methodologies and tools in kind of the reliability tool set. There's strategy tools like FMEA and RCM. There's tools around, condition monitoring. We hear a lot about, AI and artificial intelligence and industrial Internet of Things, operator rounds. Just a bunch of different things. I call it acronym soup. And what I find is, sometimes they're not rolled out the right way, and sometimes they're, we might just focus on one thing. We might just do, say, RCM or, implement FMEAs. We might just do root cause analysis. And what I found is to get the real value, you've got to put these things into work processes. If you don't do the work processes, it's simply not going to work. People need to know what their role is. They've got to understand the methodology, and there's got to be ways to report on it to make sure we're following it. So, you need all those different things put together in true work processes to make them really stick over time. So, what is the reliability performance model? Well, there's no rocket science here. There's really three components. There's build a strategy, execute that strategy, and then evaluate to make sure that you're getting the benefits that you had anticipated when you built the strategy. Okay, so when we think of strategies, we think of things like RCM and FMEAs, ways to make sure that we've got maintenance and operational strategies to ensure that the equipment gives us the reliability performance that we need. Okay. Now, a lot of people drop the ball there. They do a really good job of criticality and strategy, but they just never get over the hump to get those into the execution systems like SAP and Maximo and other EAM systems, as well as in our operator rounds. So all these tasks that come out of a strategy, they've got to be implemented in a work process. So you don't get any value at all from building strategies unless you execute them. Okay, and you'd be surprised how many people spend tons and tons of time building strategies, and they never get over the hump to execute them. So obviously they don't get a lot of value. And then on the tail end, we got to make sure that we're actually getting the value, and that's where the evaluation process comes in. Making sure that we're doing the tasks. Hopefully, we're doing the tasks. So we want to look at different metrics to make sure that we're getting the optimal performance that we had anticipated. And when we do see areas where we're not getting the performance, that's where tools like root cause analysis come in. They can kind of help us understand why we're not getting that performance. And in many cases, we find that we just maybe missed a failure mode, or there's just something that we missed in our strategy. And sometimes in that evaluation / root cause analysis process, you'll pick those things up, and you can keep your strategy kind of evergreen. So this is what it looks like, kind of a big picture, right? So on the left side of the screen, you've got strategies. Okay, so there's a couple things around strategy. Step one is, do we know the criticality of our assets? Okay, not every asset is highly critical. Okay, and what you'll find is actually a small portion are actually highly critical. So you got to think through. If we've got 50,000 assets, some are going to be super important. They might have huge safety implications if it fails, or environmental, could shut the whole operation down. And for that equipment, we need to have a really rigorous strategy. Okay. Then there's some equipment that's in the middle, and then there's some that's less important. So, criticality just helps us define what our strategy process ought to be. Okay. Now, I'm not going to get into the different strategy tools. I think most people are familiar with RCM, or Reliability Center Maintenance, and FMEA, and there's various techniques to do that. But I think the lion's share are going to come out of the output is going to be in these boxes right here. Okay, so you got to have a good strategy for material management. Okay, so as part of a strategy, you want to think through what spare parts do I need? Do I need to keep them on site? Do I need, I got a local vendor and I can get the parts readily pretty easily. So I don't want to have to store those in the storeroom, but I still want to make a material number and I want to put it on my bill of materials so that I know how to get that component when I need it. Okay. Now for the stuff that's got long lead times or it's very difficult to get, critical equipment, we want to make sure that we have those in our storeroom so that, and we take care of them in our storeroom so that when we do need them, they're readily available. The operator is with the equipment most of the time. Arguably, 90, 95% of the time, the operator's with the equipment. So if the operator's with the equipment, it makes sense that they ought to be looking for things that could be, deviations in performance. So that's where processes like operator-driven reliability come into play. Okay, that was one of the big things that I did when I worked at the paper mill. Is we implemented an approach for collecting field data, and we did it on mobile devices, and it was highly effective because we got real good information from the eyes and ears of the people who are closest to the equipment. Okay, and it also works great when if you got an older site like we did, it was over 100 years old. A lot of our equipment didn't have diagnostic information that we could get to, instrumentation and that kind of thing. So the only way to get that good data was to actually have someone go out and look at the equipment and document it in some way. So that's a big thing that would come out of an asset strategy is what are you looking for? What is the operator going to look for? Even maintenance, what could they look for on the equipment to let us know that we've got a pending problem coming? Preventive maintenance, that's sort of your basic time-based maintenance. We try not to do that as much as we can, but sometimes there's no alternative. So there's still some processes where it makes sense to do preventive maintenance. Condition-based maintenance, that's where you go out in the field and you got experts in vibration analysis and infrared thermography and blue boil analysis and a host of others to be able to kind of tell us with the equipment running what kind of things do we have coming for us? What kind of conditions are telling us that our assets might be getting sick? Lubrication. Lubrication is the lifeblood of any rotating equipment. Okay, so you got to have really good processes around lubrication storage, lube oil analysis. We got to have trained people who really know what they're doing, whether they be operators or dedicated oilers. Making sure that they know what they're looking for, they know how to lubricate the equipment. We got all our grease fittings, we got all documented, so we make sure that we're getting them all. So lots and lots of things around lubrication. Operational procedures and processes. How do we start up the equipment? How do we shut down the equipment? Again, operators run the equipment, so we can't run our cars 100 miles an hour all the time, or the car is not going to last. Well, we can't run our equipment out of specifications either. So, making sure that our operators have good training, making sure they understand how the equipment is supposed to work, how to turn it on, how to shut it down, that kind of thing. Asset modifications and redesign. You might want to think of this as, maybe capital work. Sometimes, the assets have gotten so old or obsolete that the only way they can perform their function is to be able to spend a little capital to make sure we can get that to work. And then finally, compliance management. Generally we're really good at this, but this is around things like fixed equipment inspections and governmental or insurance-based inspections, things that we're required by either by law or by insurance companies to make sure that we do. So we got to make sure all those are covered when we're doing an asset strategy. Okay. Then in the middle, we have our execution phase. Now it doesn't look very big, but for instance, we had a huge process for doing our maintenance. Everybody kind of had their role. We had a planner role, we had a scheduler role, we had engineer role. Tour maintenance is what we used to call it for shift maintenance. So all these different groups had their roles, and we had all the different steps about basically from the start of a work order or a work request all the way to the execution of the work, making sure that that was all documented so that people knew exactly how to execute the work. Okay. You know, in the context of strategies, a lot of that work management comes from building maintenance plans in your EAM system, where those PMs fire and say, okay, go check this, go check that once a week, go do this once a month. So all that work is just coming in, and it ends up in the backlog of the planner, so that you don't have to remember all those things. The software is taking care of all that for you, and we've given it the intelligence of our strategy to make sure that we're doing the right tasks at the right time. Okay. Operational work processes, that's how operations gets their work done. And then finally, in kind of engineering or capital work that needs to get done, generally people have really good work processes around doing capital work. Okay. So even though it looks a little small here, that's a huge part of getting the value, is actually executing the strategy in the field. Okay. Now, on the tail end of this model, you look at it and say, well, I'm doing this work. I'm doing the maintenance. I've got operators going out checking equipment. I've done some capital improvements. Am I seeing value? Am I seeing the improvements? So, one branch is we can review our asset health. So we can look at health indicators on our equipment, and we can look and say, wow, we've got a high vibration on that piece of equipment. Or, hey, our Lubel analysis is telling us we're going to have an issue with that piece of equipment. So from there, we want to make sure that we act on those impending failures. Then we look at our metrics, and we start to see that, wow, we're having repetitive failures on, compressor 102 or pump 407. So if we're having issues where we're having repetitive failures, that's where our root cause analysis model comes in. And from there, once we go through our detailed root cause analysis, then we implement our corrective actions. And in a lot of cases, it's as simple as updating our strategy. Because a lot of times we either missed the failure mode when we were doing our strategy, something maybe the group didn't think of, or maybe our task that we came up with to mitigate that failure was not right. Maybe we should have been looking at something once a month, and we had it down once a quarter. Okay, so that's how you keep it evergreen, is constantly monitoring your strategy, seeing where we're having issues, understanding the root cause of those issues, and then making sure that we have a process to implement corrective actions, and then update our strategies as necessary. Okay, so pretty simple, and it takes a lot of thought, but everybody has a role in this process. We have people who develop the criticality, people who help develop the strategy, people who actually implement the work. I mean, that's a broad number of people in our sites. And then on the tail end, we've got reliability teams and maintenance teams who are evaluating that data and coming up with the root causes and understanding the root causes and implementing the corrective actions. Okay, so in a nutshell, you got strategy, and you've got certain things you do within a strategy, or the outputs of a strategy. Okay, then you execute, and again, this is arguably the most important part, because if you don't do this, you don't get any value. And then on the back end, we review KPIs, we look at our corrective action management process. Our root cause analysis, I found, is one of the greatest and most inexpensive ways to get benefits in a plant, is to understand why equipment is not performing. Okay. So, around criticality, I like to throw this in, but all equipment can't be highly critical. If everything's critical, nothing's critical. Okay, you can't manage 80% of your equipment being highly critical. So just school of thought here is 10 to 15% of your assets are probably highly critical. Okay, and it makes sense to have a more rigorous approach to building a strategy, things like RCM or FMEA, or just something a little more rigorous. The stuff, and probably the bulk of your equipment, is going to be medium. That's where we look at using asset-specific templates, or kind of reviewing manufacturer recommendations and maybe adjusting them for our particular services. But a little less rigorous. We still have a strategy. It's just not quite as rigorous. And then finally, our low criticality stuff, we do our basic care. We have our operators looking at the equipment. And in some cases, it may run to failure. It may actually be less important to let it run to failure than it is to try to prevent it. Now, how do you make all this work? Well, I know for me, and probably maybe one of the most important ones was management support. I was super lucky. I had a mill manager where I worked who was highly supportive, gave me a lot of resources and a lot of flexibility to do what I needed to do. My boss, who was a maintenance and engineering manager, again gave me the reins to be able to do what was needed when things weren't going well and I needed organizational support. Those guys were there. So I had operations helping, I had maintenance helping, I had the mill manager helping, and things really move when your bosses think something's important. Everybody thinks it's important. Okay, if your boss doesn't care, probably you don't care that much. Okay, so management support is huge. Always constantly communicating the message. We used to try to make sure we talked about improvements we were making. We had these giant thick stock pumps that we needed for our bleaching operation. We had a lot of failures on those for years, and we solved that problem, and we improved the reliability of those things by 200%. So we communicated those successes to let people know that this stuff works, and it's saving the company money. We're getting better throughput, and it makes people's lives a little easier. We're not having to fix equipment in the middle of the night so often. So all around it's beneficial. Tools and technology, making sure you got good tools, good software to help you manage all this. Obviously defined roles. Everybody's got to know their role in this process. And then holding people accountable. If somebody's not doing what they need to be doing, we need to coach them. We need to encourage them and coach them. And, if we find that they just can't do it, and they, maybe we've got to find an alternate role or job for that person. But, generally that's not the case. Generally we can coach people and get them to where they need to be. Just kind of on the tail end of this, prerequisites. It really helps if you've got an asset hierarchy already built. Generally in a big site, a chemical plant or a refinery, paper mill, generally do a pretty good job of having an asset registry and it's built in a hierarchy in their EAM system. That's kind of baseline. If you don't have that, you really need to focus on that first to make sure that you got a registry of your assets. Number two, you want to have a baseline asset characteristics. For motors, you want to know RPMs, frame size, all the different characteristics around a piece of equipment. And we talked about this earlier, but then you want to get into making sure once you got your asset registry, do we have the criticality defined? Do we have the detailed work processes? Do we have a change management plan? Do we making sure that as we go through this change, are we managing that change? Are we helping our employees through that? And then of course having defined KPIs. Now people go crazy with KPIs. We don't need 100 of them. Generally there's just a handful that kind of look at different aspects of this model. Might be a handful of maybe 8 or 10 that kind of give us everything we need. Okay, so I wouldn't suggest having 1 or 2, but I certainly wouldn't suggest having 100 either. Okay, so just kind of a small amount that we can actually manage. Okay, so thanks for listening. If you like what you heard, give us a shout. Check us out at www.prelical.com. Again, that's spelled Prelical. The P and the REL stands for liability, and the PICAL is kind of the practical part. Again, I had a low budget for marketing, so it is what it is. So anyway, check us out, Prelical.com. We'd love to hear from you. If you like what you heard, give us a shout out.
And that was amazing content from Ken, as usual. One of the Latinos. I'm bringing Bob on the screen now because Bob is stepping in for Ken today. Of course, he's willing and able to step up to the plate for Ken. Ken may have some bills to pay after for Bob stepping in, but that's okay.
And we do have the same father. You can look at us and you could say they're from a separate. He's adopted, but we do have the same father.
And I have one quick question for you, Bob. We have this coming out from Ravi Ramdev. He's saying that he usually has trouble getting the feedback, the feedback phase of this loop. And that's something we see across the industry. That's the most problematic part, getting that feedback and being able to put it back into the loop. Do you have anything that you can add to that?
Well, Ken mentioned that really at the foundation of all of this is management support. So if there's a feedback loop and then people aren't doing, they're not doing what they're supposed to be doing related to that. If this is like true of anything, if there's no negative consequence for the bad behavior, then you've just eroded the standard. So this is called normalization of deviance. It's an overused term, but I think that there has to be, for people that are not complying with the feedback loop, there has to be a negative consequence that acknowledges that, I'm not saying hard discipline or anything, but if you don't acknowledge that you didn't do the tasks you were assigned, then what's the purpose of having the task? So yeah. I think the feedback loop also has to have a checks and balances in there that says if this isn't done, then this will happen. There's got to be a backup mechanism, or there has to be something. Otherwise, you're never going to strengthen. And when you're asking people to give you information and collect it, don't just make it a task for them, but give them the reasoning of why you're doing it. Make them aware of why it's going to be good for them too to collect that data, because it's likely going to remove stressors from their life by not having the unexpected failures that are likely to occur. So by implementing these feedback mechanisms, you're trying to be proactive, which should, if we communicate the reasoning correctly, it should help whatever they do for a living.
Mm-hmm. And one of the questions that we got both from Christopher and another question that we had was about asset criticality, assigning the value to the criticality of assets. So Christopher asked this, as well as Morakino, what does asset criticality mean to you? And I know Ken had a slide where he had the highest criticality, medium criticality, and then low criticality. So how do we address that part?
Well, and this depends on the organizations that you work for, but certainly high hazard industries, it's a lot more comprehensive than in non-high hazard industries, and a lot of that is regulatory based. But it's not binary, as Christopher's making a comment there. Is it critical or not? Like Ken shows, there's stages, or there's shades of criticality. And if you go to people like Suzanne Greenman or Jose Safante with the RCM is one of the more well-known ways of determining criticality. And when you get into that, it does get much more sophisticated in getting down into the impacts on safety, the economics, and reliability. So it's not just what it means to an individual person, but it's to the collective organization.
All right, that's a great answer, Bob. And we are just out of time, but I'll definitely invite you contact Bob on this platform or even on LinkedIn. He responds right away most of the time. Mm-hmm. And just be able to contact him and look out for the other great presentations that we have later on today. All right. Thank you all so much for your time. Bye.
Thanks, folks.